start a new chapter on a reciprocal internal combustion engine. So, this type of machine are engines or thermodynamic motors. It means that they exchange heat with a hot and a cold source. So they take heat from a hot source, give heat to a cold source, and use this heat transfer with the two sources in order to provide the mechanical work that can be used for something, either for the locomotion or for example, electricity production. As the other cycles that were studied before, like gas turbine cycles or steam turbine cycles, the thermodynamic principle is a bit the same. We take a fluid, this fluid is compressed, then at high pressure this fluid is heated, and then this fluid is expanded. And the technical work or the work that is recovered during the expansion is larger than the work of the technical work which is required for the compression. So the base idea is the same. Now the new thing for this kind of cycle is that these cycles are reciprocal. This means that the different transformations are taking place one after the other in time. So now the thermodynamic point of view will be a bit different. We'll be interested into the transformation between an initial state and a final state instead of open transformations that were studied for the other cycles before, where the interest was between the inlet state and outlet state. So now we will study these different transformations in time that are taking place after each other. It's also called reciprocal because there's an up and down movement of one of the device, which is the piston, and there is a conversion between this up and down movement to a rotational movement on the crankshaft. Then second particularity of this cycle is that it's an internal combustion cycle. It's always the case for reciprocal internal combustion engines. It means that heating takes place due to the combustion of a fuel inside air inside the cycle. So it means that we have for sure an open cycle because we cannot transform the smoke back to fresh air as we have at the inlet of the cycle. So all these kind of cycles will be open cycles. So most of the reciprocal internal combustion engines are based on a piston-cylinder system. So I will take a bit of time now to explain the different features of this kind of system, and then in the next videos we'll be looking at the two major cycles that can be developed with reciprocal internal combustion engines. So we have a cylinder that's a volume in which a piston will have an up and down movement. So the piston will change the volume we have inside the cylinder. The piston is connected with a connected rod to a crankshaft, and there is translation to rotation, movement, transformation thanks to this system. At the upper part of the system there are different devices, and in particular there are some valves, at least two, but can be more than two, and at least one of these valves is called the intake valve. It's the valve with which the fluid will be inserted inside the cylinder, and an exhaust valve in order to let the fluid go out of the system. The diameter inside the piston is called the bore diameter, and there are some special names depending on the state of this whole system. The piston is having a sinusoidal movement between a highest position and a lowest position. Because it's a sinusoidal movement, then it's like if the piston is stopping at this highest position and also stopping at the lowest position because it's changing direction. There's a name for these two positions. It's called the top dead center, or TDC, and the bottom dead center when it's at the bottom. Then there's also a name for the remaining volume that we have at the highest location of the cylinder above the piston when the piston is at the top dead center. The name of this volume is called the clearance volume. Then there's also a name for the difference of volume between the top dead center and the bottom dead center, and this is called the swept volume. This is a brief description about the system that we have at the core of reciprocal internal combustion engines.